Okay, I am going to make for you guys a rather lengthy and multi-part video going through the 2015 released STAR test that I've been having you work on in class. This is a copy of the formula chart that you're going to get on the STAR test or the end of course exam. You can see there's 3 sections, factoring, 4 sections, factoring. There's the 2 special types of factor patterns, difference of squares and perfect squares. Properties of exponents. Here's all of our laws of exponents. Information dealing with linear equations, standard form, slope-intercept, point slope, and the slope formula. And then quadratic equations, standard form, vertex form, quadratic formula, and the axes of symmetry. So based on the formula chart, we can assume most of the problems on our test are going to be dealing with either linear or quadratic equations, the properties of exponents, or factoring. Now, there may be some other things, certainly domain and range, exponential functions will come up, but if this is what's on our formula chart, then we can expect this to be the focus of the test. This is the old formula chart. It's got some of what we need, but not as much. Pythagorean theorem certainly isn't going to be much help to us at all here in algebra. We just won't need that. And even though this is included on this test, I do not think this is going to be given to you when you take the test. And I don't know that you would need this if you forget a basic formula, maybe. But I don't think you're going to have a copy of this. It's only going to be this formula chart right here. Okay, so they're going to give us a piece of blank graph paper. And here is question number 1. And this would be under the linear equations, data analysis, scatter plots. The scatter plot shows the number of visitors to a beach each day and the high temperature in degrees Fahrenheit for that day. Based on this scatter plot, which statement appears to be true? There is a nonlinear correlation between the high temperature and the number of visitors to the beach. That's clearly false. It would be very easy to draw one straight trend line through that data. And that line, it's a linear correlation, so we'll rule out the possibility of a nonlinear correlation. When the temperature is above 100 degrees, fewer than 150 visitors are expected at the beach. So let's go to 100 degrees, 85, 90, 95. This must be 100 degrees. And let's see where our trend line is above 240. So that can't be true. We would expect there to be well over 150 visitors, not fewer than 150. There is no correlation between the high temperature and the number of visitors. That's not true. There is very clearly a linear pattern to this data. The dots trend upwards. So by default, or by process of elimination, D is going to have to be correct. When the high temperature is between 75 and 90, 75 degrees and 90 degrees, more than 120 visitors are expected at the beach. And that does look to be correct. Here's 120, and that's the closest we're going to be able to get to a correct answer, so that's what we're going to choose. Number 2. This is a question about reasonable domain and range. A man bought X boxes of donuts for for $3.49 each. He paid with a $50 bill and received the correct amount of change. If he received more than $10 but less than $20, which inequality represents the number of boxes of donuts he could have bought? So we're going to identify a minimum value and a maximum value. If he received $10 change, that means he spent $40 on donuts. And if he received $20 change, that means he spent $30 on donuts. So how many boxes of donuts, X, did he buy? Well, if we know the cost of the box and the number of dollars that he spent, we can use division to figure out a minimum and a maximum. This is the type of division problem where I would expect you to use a calculator. It's perfectly reasonable to use a calculator here. 30 divided by $3.49 is 8.59, give or take. And 40 divided by 3.49 is 11.46. So that means the number of donuts that he bought has to be greater than 8.5, or the number of boxes must be greater than 8.5, but less than 11.4. So based on the minimum, if it's got to be greater than 8.5, then H and G cannot be correct, because 8 is less than 8.5. We can use a similar process of elimination for the maximum number of boxes you could have bought. X is less than 11.46. But X, since X is less than 11.46, he could not have bought the 12th box, which makes F the correct answer. He bought between 9 and 11 boxes of donuts. This one should be fairly easy based on what we've been learning in class. Number 3, the graph of a quadratic function r is shown on the grid. What is a solution to r of x equals 0? Well, this graph right here, this quadratic, this is r of x. It is the function r. As we input values of x, we are looking for the outputs that make r of x equal to 0, and there are 2. Here's where the function r of x is equal to 0, and here's where the function r of x is equal to 0. This is just a sneaky way of asking you to identify the roots of a quadratic equation. Now note, this is different from r of 0. If I input 0, I'm going to output negative 50. But here I'm looking for the output of 0. When is the output 0? Here and here. These two things, these are not the same. So 50, negative 50, answer choice A, is the distractor. I'm not sure where negative 60. Negative 60 looks like the minimum. And that's not what we're being asked for. 4 is the x value of the minimum. So if you input 4, if you did r of 4, you would get negative 60. And then here, where the function touches the x-axis, that's where r of x is equal to 0. So C is our correct answer. And what that means is if you were to do R of 14, if you input 14, you're going to output 0. Okay. Just by looking at this equation right here, before I even read the problem, I know I'm dealing with a linear function. I should be able to quickly identify the slope, or the rate of change, is 1.25, and the initial value, or the y-intercept, is equal to 6. This function can be used to find the cost of joining an online music club and buying X songs from a website. Based on this information, which statement about the graph of this situation is true? The y-intercept of the graph represents the cost of each song. False. That is the slope that represents the cost of each song. The y-intercept of the graph represents the cost of joining the music club. That is true. That is the initial value. G is the correct answer. But let's rule out H and J. The slope of the graph represents the total number of songs bought by members of the club. The slope does not represent the total number of songs. The total number of songs is Y. It's the output. No, it isn't. The total number of songs is X. The number of songs is the input to the function, and the amount of money is going to be the output. The slope of the graph represents the number of songs each member buys when visiting the website. False. The slope of the graph represents the cost of each song. So slope is cost of each song. $1.25. Neither of these two descriptions of the slope are correct. Okay. This situation in number 5, this diagram represents a quadratic change. This here, the figure number, is equal to n. And the number of circles is f of n, or the output of the function. So we could build a little table here pretty easily. When I have, for figure 1, there are 3 circles. For figure 2, there are 8 circles. For figure 3, there are 15 circles. For figure 4, there are 24 circles. And for figure 5, there are 35 circles. So, this is one of our most useful strategies, creating a table when presented with information. Anytime you can translate a diagram into a table, you're in good shape, because once you've got a table, you can produce an equation. Stat, edit, and then enter your table into the list. List 1 will be the figure number, and list 2 will be the number of circles. And then we can run a regression. However, it might not be initially obvious that we need to use the quadratic regression. If we do a linear regression on the information in the table, we do get an answer, but it's not one of our answer choices. Because all of our answer choices have a squared term, it's a pretty safe assumption that we're dealing with a quadratic. But there's another way. There's another way to come to that conclusion. Find the second difference. From 3 to 8 is 5. From 8 to 5 is 7. From 15 to 24 is 9. From 24 to 35 is 11. That's the first difference. Now look at the second difference. From 5 to 7 is 2. From 7 to 9 is 2. From 9 to 11 is 2. The second difference is constant. Therefore, we know we're dealing with a quadratic. And also, since the second difference has a rate of change of 2, we have a hint as to a possible correct answer. So, let's take that same information in the table, but this time we're going to run a quadratic regression. Because our second difference was constant, we know the quadratic regression, option 5, is the best choice. And voila, the value of A should be 1, the value of B should be 2, the value of C should be 0. Which means my equation should look like this. Or, since we're using the letter n squared plus 2n plus 0. And if you add 0 to something, nothing changes. So n squared plus 2n. A is the correct answer. This strategy of building a table, entering the table into the lists, and then running the proper regression is one of the most valuable strategies we have when it comes to solving questions, solving problems on the EOC. Number 6. I don't like word problems much more than you guys, so let's just take them one sentence at a time. One wall inside a shoe store is used to display walking shoes and running shoes. There are 15 pairs of shoes in this display. There are 135 pairs of shoes in this display. There are 1.5 times as many pairs of walking shoes as there are running shoes on display. How many pairs of walking shoes and running shoes are on display? Okay, so I see a couple of equations that we can write here. There are 135 pairs of shoes in the display, so that means walking shoes plus running shoes equals 135 total pairs of shoes. There are 1.5 times as many pairs of walking shoes as there are running shoes. So, we always got to be careful here. There are 1.5 times as many walking shoes as there are running shoes. So walking shoes equals 1.5 times running shoes. Now we can use substitution. If W equals 1.5R, anywhere I see a W in my other equation, I can substitute 1.5R. 1.5R plus R equals 135. 1.5 plus 1 is 2.5R equals 135. And now it would not be unreasonable to use your calculator. 135 divided by 2.5 tells me that my number of running shoes is 54. And then I can go and look at my answer choices and do some eliminating. Anywhere I don't see running shoes equal to 54, I can rule out my answer. And then just to be 100% sure that this one is correct, we've got a value of R So we can plug that in to our equation to find the amount of walking shoes. 1.5 times 54. And I'll go ahead and use my calculator to find that answer. 1.5 times 54 is 81. So walking shoes should equal 81. This is a systems of equation problem that's set up for you to use substitution. First you write both of the equations, then you substitute the value of W from one equation into the other to solve for R, then you solve for W by substituting R. The mapping below represents y as a quadratic function of x. This is important. We're being told that we're dealing with a quadratic function. Which representation shows the relationship between x and y? So we want a function representation that matches this mapping. If I input -2, I should output -3. I don't see -2 as an input. We can't rule it out yet. If I input -1, I output -3.75. Again, I don't see the input of -1, so I don't know anything yet. If I input 0, I output -4, so that one checks out. If I input 2, I output -3. Now I don't see the number 2 in my inputs here, but if this is quadratic, it's reasonable for me to assume that if I input a 2 between 1 and the 3, I should get a value between 3.75 and 1.75. -3 is not going to be in between positive 3.75 and positive 1.75. So for that reason, I'm going to rule out answer choice A. Answer choice B. This is my input line. The x-axis are where my inputs are happening. The y-axis is the outputs, or really the line, the curve here, the quadratic. Those are the outputs. So if I input -2, I should output -3. That's clearly wrong. Already we're not on the quadratic, so B is not a possible answer. C. If I input -2, I should output -3, so that one checks out. If I input 0, I should output -4. That one checks out. If I input -1, I should output -3.75. That's suspicious because here I've input +1 and output -3.75. And if I input 2, I should output -3. So for the moment, I'm going to say this one is a maybe, and then I'm going to do answer choice D. How do I check answer choice D? I use my calculator's ability to produce a table from an equation. Now, a couple of problems ago, we entered a table and used that table to produce a quadratic equation. Your calculator can reverse the process. Go to y equals. You can enter an equation and produce a table. So y equals 2.5x minus 4. 2.5x squared minus 4. And we could graph it, but the graph isn't going to be near. Sometimes the graph is helpful, but I think the table is going to be more helpful. Because now we can match. We can look at our mapping. If I input -2, I should output negative 3. Input negative 2, output negative 3. When I input negative 1, I should output negative 3.75. When I input 0, I should output negative 4. And when I input positive 2, I should output negative 3. This quadratic matches every step of the way, which makes me believe that D is the correct answer. The real problem with C is this point right here. If it's a quadratic and it's opening upward, I can expect a shape that looks like this. If it's opening downward, I can expect a shape that looks like this. In both cases, we are going to be decreasing until a certain point and then increasing, or increasing until we get to the vertex and then decreasing. That's not what this quadratic does. Negative 4, negative 6, so then I increase to negative 3, but then I decrease again to negative 4 before increasing again to negative 3.75. So this shape, these points, let's go ahead and plot those to really show why C cannot be correct. Here's my graph paper provided to me by the state of Texas. Let's make good use of it. This is another strategy you can always use. Sketch a graph or draw a picture. When I input negative 4, 1, 2, 3, 4, I should output 1, 2, 3, 4, 5, 6. Negative 6. Input negative 2, output negative 3. Input 0, output negative 4. Input 1, output negative 3.75. This shape is not quadratic. So therefore, because this is supposed to represent a quadratic function, C cannot be correct. Okay, now this is a relatively simple problem that I can admit to teaching badly back in September. It's a question of slope. The slope of a line passes through these 2 points and is 1/8. What is the value of W? So we're going to go back to our formula chart and we're going to make use of our slope formula. y2 minus y1 divided by x2 minus x1, where y2 and y1 are points. They are ordered pairs. We have x1, y1, that's one of my 2 points, and there is x2, y2. That's another one of my 2 points. So, starting with the formula, m equals x2 y2 minus y1 over x2 minus x1. Let's do some substitutions. We know the slope is 1/8, so I'm going to plug that in for m. y2 is 4, y1 is w, so my numerator is 4 minus w. x2 is negative 10, y2 is negative 6, so that's negative 10 minus negative 6. There's a double negative there. Let's simplify. 1/8 should equal 4 minus w divided by negative 10 plus 6, and negative 10 plus 6 reduces or simplifies to negative 4. Now we've got a simple cross multiply and divide. These 2 multiply together, these 2 multiply together, not forgetting the distribution when you multiply 8 by 4 minus w, and solve. Cross multiply. Negative 4 equals 8 times 4 minus w. Distribute the 8. Negative 4 equals 32 minus 8w. Continue solving for w. I'll subtract 32 from both sides to get negative 36 is equal to negative 8w. Divide both sides by negative 8, and you get w equals 36 over 8. 36 and 8 are both even numbers, so that means w must be equal to something divided by 4. I think it's 18. 18 and 4 are both even numbers, so w must equal 9 over 2. And that is our answer choice, 9/2. Use the slope formula. Plug in the information that you have, the points, the slope. Simplify as much as possible. Cross multiply, not forgetting to use distribution. Solve for w. The first thing I see and think when I see this problem is slope and y-intercept. The population of Webb County, Texas from year 2000 to 2010 is shown in the graph. If the trend shown in the graph continues, what will be the population of Webb County in 2015? Well, how much has the population changed in 10 years? From 193 to 250, that's an increase of 57,000 over the course of 10 years, which makes for a slope of 5.7 thousand. If we allow for growth to continue for 5 more years, how big will the population be? Well, 5 years growth at 5.7 per year. That's 5, 3, 25, 28.5. And let's add that to the 250 we already had. So 278.5 thousand, and if you want to multiply by 1,000 to see the actual number, that is perfectly fine. Determine the slope. Use the slope to make a prediction or gain information about the future to answer the question. We also could have written the linear equation 5.7x plus 193, and then we could go to our calculator, enter in the equation 5.7x plus 193. The graph is not going to help us very much. We'd have to change the window, but the table will be immediately helpful. There's 0, there's the year 2000, 193. There's 5 years in, which we don't really need. There's 10 years in, 250, exactly what we'd expect. 15 years after 2000, 278.5, 278,500. Okay. These will be the last 2 problems I include in this video. A city employee paints curbs in parking lots and replaces road signs. It takes 0.5 hours or half an hour to paint a parking lot curb and 2 hours to replace a road sign. The function below can be used to find C, the number of parking lot curbs and employee paints the employee paints when he replaces our road signs in a 40-hour work week. And they've given us an equation that we're going to use to solve our problem. If the employee painted 200 curbs in 1 week, how many road signs did he replace that week? Well, in this equation, C represents the number of curbs, and R represents the number of road signs. So I can take my 20 curbs and plug it in for C. 20 equals 40 minus 2.5R divided by 0.5, and solve the equation. How do you cancel out a denominator? Doesn't matter what it is, just multiply both sides by that denominator. Multiply both sides by 0.5. Half of 20 is 10. The denominator is gone. 40 minus 2.5 R, and solve. Subtract 40 from both sides to get negative 30 equals negative 2.5 R. Divide both sides by 2.5, or negative 2.5. Perfectly acceptable time to use a calculator. Negative 30 divided by negative 2.5 equals positive 12. He replaced 12 road signs in the week. Here's another way. Again, you can use the calculator and the table. Y equals the fraction 40 minus 2.5 R. Our calculator uses X. Since that's the whole numerator, I'm including it in parentheses. Divided by 0.5. I could graph it. It'll give me a line of some kind somewhere. Again, the graph is not really going to be helpful. I'd have to change the window to go find it. But the table is very powerful. We are looking for the time when I have 20 curbs. How many road signs did it take to produce 20 curbs? And this is another problem where I think I'm going to be able to use the table feature of the calculator. Customers at a bank are charged a fee when they exchange US dollars for foreign currency. This function can be used to determine the number of Japanese yen customers receive in exchanging X dollars when X is greater than 5, greater than but not equal to. Which table shows this relationship? Well, we've been given a linear equation, and I have a calculator that is capable of producing tables when I enter equations into Y equals. So that's what I'm going to do. I'm going to skip the graph and go straight to the table after I enter in my information. And I'm going to look for one that matches. We want to get all the way to 50. There's a shortcut. Second window takes you to the table setup. And let's jump straight to 50. Based on all of the inputs in all of my tables, I'm going to set my table delta, the amount I'm going to count as I go through the table, to 5. Back to the table. At 50, I should have 43175, so A is out. At 65, I should have 4710, so B is out. Let's see here, at 50, aha. Now just because it matches the first entry doesn't mean it's going to match every entry. 3532.5. At 85, I should have 6280, good. At 120, I should have 90 27.5, which I do. And at 200, good thing we're counting by 5, I have 15,308. Oh, well, now let's be careful here. Let's be sure we read the table carefully. This column is rounding up already, but the actual value is right here on the y equals, and that matches directly. So C has got to be the correct answer. And if we really wanted to, we could scroll back down and check one of the entries in table D just to be sure. At 45, I should have 3140, but they're saying 14,130, so D is definitely wrong. And 11 is C. So there you go. There's the end of part 1 of this video series on solving this released EOC. At least 3 or 4 times I entered an equation into y equals and looked at the table to help me get my answer. And in one instance, I entered into my lists. I entered a table in and then used my calculator's ability to create equations from tables to get my answer. Knowing how to use tables and equations, the table feature and the list feature, will, for many people, be the difference between earning the advanced ranking and just passing. And that's fine. This is one skill that I really want you to master. We'll pick up in part 2.